Okay, in this video what we're going to do is create the group command. Let's go ahead and jump back over to the whiteboard real quick. Let's talk about how the group command works. Basically, it works as follows. Let's go ahead and just draw a little bit of a divider line in here. You can type two different versions of the group command, if you will. You could type group and then node 1, node 2, or you could use group node, where node 1 and node 2 represent the name of a valid transform node. Now, how does group work? Group first creates a brand new transform node and then takes the specified nodes, be it 2 nodes or a single node, and makes those nodes children of the new transform node. Okay, so in this particular case, the first one, what would happen? It would start out like this. Here would be node 1, and here would be node 2. After we ran the group node 1 space node 2 command, we would have this. TXFRM, just for quick representation, so a transform node, and parented to the transform node, we would have node 1 and node 2. The other version of group, if you will, the different implementation, taking in just a single transform node, would look like this. Before would be, we'll just say node 1. Afterwards, you would have your transform node, and node 1 would be the child. Very simple to set this up. All we need to do is make sure first that our arguments length is rather 3 or 2. So if it's 3, we're going to do the very first scenario, 1, 2, 3. And if it's a length of 2, 1, 2. If it's anything else, then we need to give some sort of error message that says, hey, you're only allowed to do 1 or 2 nodes. Then what we need to do in both cases is we're going to need to verify that the nodes we've specified to be grouped do indeed exist as transform nodes. And if they do, then all we need to do is go ahead and call upon the transform node.group static method that we created earlier in the DAG engine and send in node 1 and node 2, or simply send in node 1. All right, that's pretty much all we've got to do. So let's go ahead and jump over to Visual Studio.
All right, and let's create the command. New item, command template, command group. And inside of this command group, the first thing we need to do is some arguments length checking. So first thing, if we have 3 arguments, so 2 parameters. So if arguments length is equal to 3, then we have the 2-node version. Otherwise, else if, we could have another possible valid scenario, and that is if arguments length is 2. So that way if we have the single node scenario.
Okay. Else?
Otherwise, we have our error scenario, so we output,
you must specify 1 or 2 nodes in order to group.
Order to group.
Perfect. Okay, so let's go ahead and jump back up to our first scenario where we've got 2 different transform nodes. Now we need to check. We need to search and make sure that both of these nodes do indeed exist.
All right, so let's make some transform node references. Let's have a node 1, and then we'll do a search from transform node find.
Okay, you did a new one there that kind of blew my mind.
I must have brushed N before I got to T. Probably still thinking of node. Instead, we want the static transform node find, of course. We want to look for arguments 1 as the first given parameter, so to speak. Again, cast it as transform node to make sure we only get transform nodes, and that should yield node 1.
Okay.
Of course, we have another parameter, another piece of text we're searching for, so let's make a node 2 reference where we find arguments 2 as transform node.
Okay, now all we need to do is a simple if statement that confirms that node 1 and node 2 are both not null.
So if node 1 is not equal to null and node 2 is not equal to null, then we have a case where we can continue.
Yeah, where all we got to do is call upon the transform node dot group static functionality and send it. Now notice we've got two different overloads of the group method. So we've got one where we take in two transform nodes or one where we take in only one. So in this case we'll just simply send it node 1 and node 2. And we've got such a nicely designed engine. It just makes writing these commands a breeze. Alright, so excellent. So let's go ahead and do an else, and we can set our output to say one or both nodes are invalid.
So one or both nodes are
Again, we're just trying to
valid.
keep this a bit generic, guys. You can go in there and specify which node doesn't exist and all that good stuff, but by now I'm sure you know how to handle that. Alright, so now let's go ahead and just copy and paste all of that inside the second scenario and remove that node 2 out. Okay. Perfect. And then, yeah, just change the wording a little bit.
So invalid
node.
Invalid node.
Okay. And if you want to throw a period in there or something, just make it a little nicer. Okay. And let's see. I think that's everything we need. It worked out beautifully. Let's go and register the command, of course.
So back to the command manager, where we can register the group command. So this is going to be a command group, registered to the text group.
And let's make sure everything builds successfully. And it does. And let's do it. All right. So go ahead and create a sphere real quick. And do a list. And let's try the single group. So group sphere 2. And ls. And look at that. We now have, check it out, the naming held up quite well. Since group has already been utilized, group 2 now exists. And as a child of group 2, we have sphere 2. Beautiful. All right, go ahead and create, let's see, what do you want to do next?
We could
unparent sphere 2.
Okay.
Start using all of our commands. Okay, ls. Now create a light. All right. Now go ahead and group sphere 2 and light. Beautiful. All right, so now let's go ahead and group 2 and group 3. And look at that. So we now have group 4 as the parent of group 2 and group 3, where group 3 is still the parent of sphere 2 and light. That's beautiful. All right, let's see. Let's go ahead and test some of our error checking now. So we could try just group by itself.
So group must specify some nodes.
Okay, so let's specify a node that doesn't exist. Invalid node. All right.
So let's do a valid node and an invalid node. So group sphere 2 to cat and cat. One or both are invalid. So both cases are checking for valid nodes.
Okay. And if you want to reverse the order of that,
just make sure that it works the other way. So
of course, yeah, it obviously should, but
group cat sphere 2. Just make sure that we didn't accidentally type like node 1 twice when we were checking for null. So group cat and sphere 2. Well, cat is still not found.
Very good. All right. Anything else you want to add to this?
I think that's all the cases. So
I
think we're good.
It really is straightforward. Once again, we've got quite a flexible DAG engine set up for us, and because of that, creating these commands are a breeze. All right, that is going to wrap it up for the group command. Thanks a lot.